Hello and welcome to this week's What Were They Thinking? Amongst the news items we have for you this week, the world's first entire eye has been transplanted, thereby returning some degree of eyesight to an individual who had a completely dysfunctional eye. Salt has been implicated in type 2 diabetes, albeit somewhat tenuously. Several case studies of various behaviors or observed events, some of them more unexpected than others. Unusual cellular behavior during embryonic development. A chimera has been made using monkeys and rather disconcerting glowing genes. And the rather controversial superconductor paper from Korea has been retracted. The timestamps for these and other news items can be found in the description box below. Starting with transplants and eyesight, we have New York surgeons transplanting an entire eye from one individual to another. However, this is a first of kind, and although hailed as a medical breakthrough, shouldn't be seen, and no pun intended, in that light just yet. This is for a very simple reason. We don't yet know if the man who received the eye will actually be able to regain eyesight. And given that the 46-year-old man survived a 7,200 volt electric shock from working on lines in Arkansas, it's no wonder that, at a minimum, he lost his eye. In fact, his eye is just one of many parts of his body that suffered injuries. His left arm above the elbow is amputated, his nose, lips, front teeth, left cheek, and even his chin. Regaining his eyesight in at least one eye is the least of the things that he has to worry about, albeit one that will drastically improve his quality of life. At least fortunately for the individual in question, after the face transplant, a great deal of that damage has been, let's say, resolved. The ability to see, and see clearly, is the final hurdle, and arguably a sort of holy grail. And not because eyesight can't be restored. After all, there are prosthetics that will do that. But rather because the ability to transplant an eye from one individual to another hasn't been achieved in humans to date. There has been some limited work in animal models, and they have shown success, but the human body is rather difficult to work with, and often very uncooperative. For this reason, although hopeful, and with other further therapies down the track, it is possible that the eye might begin working, but at this stage, given the time frame between the surgery and the present publication of this video, eyesight has not come back into function. It's unlikely to do so of its own accord. But at least the individual in question will be far more comfortable in the way they look as far as their own body is concerned. Moving to a more theoretical study at least, the relationship between weight loss and, well, brain aging, of a kind anyway. Brain aging is a somewhat nebulous and questionable term or concept, as there's a lot of variability in between individuals. However, on that basis, there is evidence to show the brain does slow down and degrade somewhat with age. On that basis, anything that would, somewhat mitigate that process of aging would be beneficial, and diets are said to be, one of those ways to do it. For example, certain neurological diseases seem to be less prevalent in those eating the Mediterranean diet, for instance. Dieting then has been a focus, and unfortunately, dieting hasn't always shown much benefit. For example, we do know that the ketogenic diet is great for children with something like seizures. It seems to reduce their severity, duration, and prevalence. For adults, it does nothing. So clearly there's something else going on there. However, for the concept of brain aging, it has no obvious benefit. This is where a relationship between body weight reduction and brain aging, that is, reduction in neuron density and similar, shows some benefit. It is tenuously established that a reduction of as little as 1% in body weight can improve your brain function and scan results. That's the good news. Now for the reality check. First, the reduction in body weight was part of the, average, let's say. Second to that is that the brain scans were taken in an 18-month period. So obviously, if you're looking at people involved in a clinical trial like this, and there's a large time frame between scans, you might find that indeed something has changed. Secondary to that is that, well, there were 102 individuals, so it's not a particularly large clinical trial, and further to that, it's isolated only to Israel. Although it is worth noting that the data in question was somewhat more supported by other tests, particularly those around liver function, cholesterol levels, and body weight. However, the relationship between these is not as clear, although it is well known that if your liver starts to work less well, other parts of your body do suffer, given the significant role the liver plays. However, that is a secondary concern. The way they then, let's say, established this is that they gave 3 groups within this different diets. So now we have roughly 20-ish individuals in each group, assuming an equal division between the 3 experimental groups and a control group. The basic division was to give one group a Mediterranean diet with an increase in nuts, fish, and chicken instead of red meat, a Mediterranean diet group with green tea added to it, and then a group based on healthy dietary guidelines, which would be the standard for most individuals. The results were then compared to effectively a data set of 300 individuals who were supposed to have healthy brains and a given age, although this is not exactly an ideal design as a general rule. Normally you want your control group to be running contemporaneously with your actual study group. The other concern here is, well, rather more explicit. That is, 1% body weight reduction equated to roughly 2.3 kilograms, or roughly 10 pounds. That would mean that if they lost more than a few percent, say 5% of their body weight, we are talking somewhere around 10 or more kilograms of body weight reduction. And for that to be realistic, there is a reasonable probability that many of these individuals were at best overweight, if not obese. This criticism is further supported by the fact that, well, the results showed reductions in things like levels of liver fat and a lower lipid profile, and not exactly indicative of better brain function, but just a better diet and someone not being fat. In other diet-related news, we have a recent study claiming a relationship between salt and type 2 diabetes, which honestly should not be that surprising. It's well established that in order to get glucose to enter the body, you need sodium, sodium being part of sodium chloride or table salt. This leads to the, well, to be blunt about it, observational study, and therefore the results can't necessarily be extrapolated out the same way. Itself, let's say it's somewhat interesting, but we need to take this very carefully and, well, with salt. First, the study followed 400,000 individuals from the UK Biobank study. So this is a large data set that gets generated regularly, which is useful. But the researchers are based in the US, so there's some interesting discrepancies in that in terms of the ability to access it and what goes on in the background, but it shouldn't affect the basic data. Then, from this roughly 400,000 individuals, 13,000 of them developed type 2 diabetes, which is roughly 3%. By itself, at least in theory, reducing the prevalence of type 2 diabetes by 3% would be a massive achievement, but this is where we need to start taking potshots at the study in question. First, it's an observational study. This means they can describe a correlation between events, but they can't establish causation. It's quite simply that. As much as it may sound harsh to say, their study can only really say this is a pattern we found, not a relationship that's necessarily true beyond what we've looked at. That's, well, to be blunt about it, kinda weak, and it's not really very good, but it gets worse, unfortunately. The study itself, other than relying entirely on observational data, had a simple question added to a survey, which was, do you add salt to your food, and specifically exclude salt added when you are cooking food? Which isn't exactly ideal. It's not ideal for a very simple reason. You're relying on individuals A, to know what they add to their food in all occasions, to recall correctly, and to be honest in their responses. Yeah. The other issue, though, is the responses were categorical, with never or rarely, sometimes, usually or always. And that means we're not able to establish much of a dose response here. All we really know is that always could mean that they add a tablespoon of salt to their food, or they might add just a sprinkle or a pinch of salt. Barely anything worth noting. Yeah. Again, the dose dependency, we just can't establish it. And further to that, well, to be quite blunt, most of the time, salt consumption is not going to be coming from the direct addition of salt to someone's food. The idea of adding a tablespoon of salt, although an extreme example, isn't so far away from what actually happens. The UK average daily salt intake is about 8 grams or 2 teaspoons. 8 grams being about a third of a tablespoon. This means that you don't really have to worry so much about what people are adding to their food as what's already in their food. There are also, well, to be blunt with this, a bunch of other issues with the design of this study, and the conversation goes into a great deal more detail on exactly what these criticisms are, and it's a good idea to have a read of this if you are concerned, let's say. Going on to a series of case studies now, each of them are more bizarre than the last. First, we have a man who had received breast implants. Well, specifically, the breast implants were what saved his life, which is what's odd here. The way it works is that the 34-year-old patient had developed a drug-resistant bacterial infection, and as a result, his lungs were so badly damaged that they just couldn't be resolved. The reality is, he had to have a complete lung transplant in order to be able to survive. The challenge here is that, well, he was so badly infected, they couldn't be able to replace his lungs as it was. The solution was to, quite literally, take his lungs out entirely and attach him to a ventilator machine that would perform the same function as his lungs by oxygenating the blood internally to the machine, rather than the normal process of, well, providing oxygen to his lungs. However, that did carry with it one notable issue. The lungs take up quite a bit of space within the thorax, and to be quite blunt with you, the thorax needs that volume to be filled. It's a nature of how the rib cage, heart, and everything else works. If you've got a giant hole or void in your chest, you're going to have issues. The solution was to add a couple of double D breast implants. The good news of a kind is that, well, after having had his lungs removed, the breast implants put in place, and waiting just a day, the hospital he was based in was offered donor lungs, which were able to be put in, and to be clear about it, the necessity of this was made clear once they gave x-rays of it, showing that the lungs had basically begun to liquefy from within due to pus and infection. So no, there was no possibility of anything else ever working. To a second case study, although again largely disconcerting and slightly more bizarre. Rather than discussing in terms of the individual's body beginning to break down, it's instead a child who had, well, to be quite blunt about it, stomach cramps caused by magnets. Yeah, well, we call them a child, they were a teenager, and that means that there's at least some unexpectedness to this. Rather than like a regular child who would just eat anything and everything they find, a teenager is expected to be somewhat more discerning in what they consume. Somewhat. In this instance, though, after initial x-rays identifying what appeared to be solid metallic masses, the teenager was sent to a new hospital where they were able to provide CT and x-ray scans that were of higher quality, identifying that yes, there were relatively large metallic masses within their stomach and intestine. The metallic masses after endoscopy turned out to be stacks of what appeared to be relatively small grey discs, about 8 millimeters or a third of an inch in diameter. These appeared to be neodymium magnets. The magnets, after being removed successfully, weren't the only issue, as the two lots of magnets that were found apparently weren't the only ones. Over the next 2 days, more such bundles of joy were found, and they were removed as well. This leads to the cause of the stomach cramps. The intestines had started to quite literally rot where these magnets had been, due to the nature of the damage they were causing. Whether, fortunately or unfortunately, the magnets were found and removed, and up to 18 of them, before the bowel was perforated. And to be quite clear, a perforated bowel is bad. Your intestines are quite literally processing food into feces. If that feces happens to get outside of your intestines, well, you now quite literally have shit inside your body where it shouldn't be. Shit full of bacteria, unprocessed food waste, and more. It's like bathing in sewage, except it's inside your body. The obvious answer to this is going to be that the individual had a psychiatric concern, but it turns out that it may not have been that. Well, not quite that anyway. It turns out that the teenager has a sleepwalking problem, and turns out they tend to eat things while sleepwalking, or at least that's what the family claims. Fortunately, after about 6 days, everything was resolved with relative ease. The final case study, sort of, is more a response to a recent TikTok trend, and that is individuals using coffee enemas. And no, this is not how you should use coffee. And unsurprisingly, it's been stimulated by TikTok. TikTok is honestly a cause of great many headaches. Let's start with the rather obvious issues with this. First of all, you are quite literally trying to put something up your butt that does not belong there. And not just the fact that, well, coffee's not going to do a great deal. Enemas, as a general rule, aren't a great deal of use unless you are trying to flush it out for a variety of reasons. First of all, they are unsafe in that respect. You are effectively putting something up your butt, and it can cause, well, damage, to be kind. The damage can come in the form of perforations, which, again, much like the previous case study, are not good for you. Theoretically, it can result in septicemia if anything from the rectum gets into the bloodstream. The fluids that can be reabsorbed in the rectum from the enema can then lead to electrolyte abnormalities and imbalances, particularly as either the body attempts to draw fluid into the rectum to deal with what it views as a foreign substance that needs to be diluted out, or alternatively, a fluid, particularly water, from the enema entering into the bloodstream and then having to be disposed of by the renal system, and in some cases, possibly death. That last one we can't do much about, even when we start looking to, let's call them examples that are actually useful, that is real case studies. Pretty much all of them found that they caused issues with the GI tract and particularly inflammation of the intestines after administration. So no, putting coffee up your butt is not going to do anything. Ultimately, there is one more element to this that is important to note. That is, the rectum can absorb some material, and let's be clear about this. Certain things can pass through the membranes of the rectum and then enter the bloodstream. This is fine if you're trying to, for instance, use a suppository. However, this also has the issue of bypassing most of the body's regulatory mechanisms to prevent absorption of certain things in the bowel. This then means that you get a relatively uncontrolled dose of the caffeine within coffee, and this can lead to issues. Considering that TikTok is advising people use this approach for things like insomnia, basically giving yourself a massive dose of caffeine via a enema isn't exactly going to help you get to sleep anytime soon. Going from what is frankly rather stupid ideas to at least somewhat more promising news, although relatively early news. It's early news in that it's been pre-published on the bioRxiv archive, but also early in that it relates to zebra fish embryos. The gist of what they found is that the cells in question developed networks connecting each other in various ways, and it allowed them to move various materials and send signals to each other during embryonic development, as opposed to research from last week which found that there could be effectively vesicles remaining after cellular division for cancer cells. These are literal direct connections between cells that can shuttle material around between cells. The cells can move a great deal of content, and we're talking about some relatively difficult material to move under normal circumstances, and the only other example known to date would be that in cancerous cells. In this case, the channels that are between the cells can move various chemicals, RNA, proteins, organelles even, but also unfortunately viruses and bacteria. Shifting back to diet news, although this time slightly more promising news, we do have a study between the consumption of wasabi and cognitive function. Yeah, this is going to be another one that you should take with salt, although given the topic and the nature of condiments, perhaps it would be more appropriate to say wasabi and soy sauce. The difference between this study and the previous study is that this was an actual clinical study of sorts anyway. The, let's call it a trial, involved 72 adults, all elderly, so over 60, but only ran for 12 weeks, so this is a slight concern as far as the study goes. One group taking wasabi tablets once a day, while the other group took a placebo. The results were then studied, and between the start and end result, the cognitive tests of episodic memory and working memory were better in the wasabi receiving group. However, that is the only areas in which improvement was observed. Compared to the control group, nothing else was improved. The important caveats to this study are 1. That they didn't establish any dose dependency, so they don't know what effect wasabi intake is having. They also didn't measure how much of what was being consumed was providing the necessary ingredient. So, without knowing how much was being given and the exact effect in terms of the inflammatory markers that were meant to be reduced, we don't know the effect in that term. Secondary to that, we also don't know whether or not this is why Japan makes anime. In terms of anime, China might well be trying to recreate Full Metal Alchemist, as they've created a chimera.
なんだ、いるじゃないか。
やあ、できたよ。完成品だ。人語を理解するキメラだ。
Well, a monkey chimera rather than a dog-girl chimera. The creepiness of it doesn't just end there, though. What they made is a monkey that has glowing fingers and green eyes. The chimeras, at least relatively recently, aren't necessarily new. What's important here is how they made the chimera. First of all, what they've done is take 2 distinct and entirely separately fertilized eggs. This means that there are basically 2 different monkeys that would be born otherwise. They've then fused these together to create 1 monkey in the end. The 2 monkeys now effectively grow together in the same body, and this is part of what makes it a chimera. The cells from the 2 different, let's say, lineages were found in the brain, heart, kidney, liver, the GI tract, testes, and even cells that were becoming sperm, which means that, in theory, this chimera could pass on its truly messed up genetics. The percentages of different cell types did vary drastically between the tissues in question, from as little as 21% all the way up to 92%, and the highest percentage was in the brain itself, so that would indicate that the degree of, let's say, incorporation by the chimera of the 2 different lineages was widely variable. And now for the news that's probably going to make you both angry and sad. The results of creating a chimera are generally going to be incredibly bad, and that's for a simple reason. The body of any animal, but monkeys in particular, much like humans, don't like when there are cells that don't belong to the self present. In this context, the self being one of the monkeys and likely the one that makes up the majority of what's in the bone marrow. When this happens, those cells in the bone marrow are going to begin to recognize the other chimeric cells as foreign and begin to attack them. And this is why the monkey only survived for 10 days. And now for why the monkey glows, and it's for a relatively straightforward reason. in order to be able to figure out where the cells of the Chimera's parts have shown up, the fluorescent proteins have been genetically modified into the embryo before they were combined. This means that when certain, let's say, genetic lineages were expressed from cells belonging to that line, they could know which one it was from. Of course, this does raise all kinds of ethical and moral issues, and there is debate around that. The first problem being that, well, the success rate is really bad. It's about half as successful as IVF, and that's still not great. The other issue is, well, you're quite literally turning monkeys into models of a disease, and then seeing them die. Yeah. Putting aside the morals and ethics for now, that's pretty much the gist of the problem and the success here. It's shown it can work, it's shown that there are drawbacks, and there are obviously areas for improvement. In other genetics-related news, we have a interesting post from Kevin Falter, a Florida researcher and professor, primarily focusing on agriculture. They've written a interesting, let's call it blog article, and it talks about, well, the issues around growing things from seed, but particularly the idea of growing, say, fruits and vegetables from seeds that you've taken back from, say, your own garden or something you bought at the supermarket, or similar. The point they make, and it's the summary of it, is that if you take a seed that's genetically modified, or most likely in the current environment a hybrid, and try to grow that seed, you're not actually going to get what the original fruit or vegetable was. And that's because the original hybrid is a mixture of two different genetics. That produced that particular plant, the plant that then produced the thing that you've eaten. But in order to get that fruit or vegetable, the original hybridized plant needed to be fertilized. And that fertilization means you've now brought in genetics from another source. Now, it's entirely possible, and it's unlikely but possible, that you will get a perfectly matching genetic strain from somewhere else to fertilize your particular fruit or vegetable. What is more likely is that you're going to get a slightly different, let's say, version of that fruit or flower pollinating yours. And that means when you get genetic shuffling during the usual process, you end up with a slightly different, in some cases extremely different, fruit seed. The fruit will be right, the seed will not. This is true even of, say, something like an heirloom variety. That is, varieties that are said to be stable and that you can take these seeds from them and plant the next year to get the same plant. You may not see any observable difference, and that would mean you've got a well-established line of plants, or you might be able to pollinate yourself using a paintbrush, and this would let you ensure purity of the seeds in question. But that's the point here, and the point of the article in question. No matter what you think you're going to grow, in most instances, unless it is a commercially developed seed and sold as a commercial product, you're not likely to get the plant you think you're going to get in the way you think you will. And that's simply due to the, nature of genetics, and specifically a fertilization of fruits and vegetables. As noted in the article, most commercial cultivars are a graft for exactly this reason. The idea is to take an established, known good tree or similar, and apply it to rootstock. And by grafting it, you know exactly what you're going to get in terms of the tree itself, as you already know what it's like. You've just taken a branch off of one good tree and put it onto rootstock. It's a clone. A different kind of clone, but a clone nonetheless. On to, news around the superconductors and retractions. We have the retraction of the superconductor paper from Korea that, came out to a great deal of acclaim and, then controversy. In short, the study was originally supposed to have found a viable room temperature superconductor. Now, this would have made a lot of technology a lot more viable, given that otherwise superconductors require extreme cold or extreme heat in order to be able to, well, function as intended. Largely extreme cold, given that they generally generate extreme heat. Despite these initial findings, before Nature, the publication, retracted it, 8 of the 11 authors had already sent a letter to the journal requesting for exactly that. And it all comes down to some of the data being unreliable, let's say. And this is fundamentally what Nature found once letters of concern started piling up. The electrical resistance data presented in it seemed to have, discrepancies in its reliability. And these concerns were ultimately substantial enough that Nature described it as substantial and remain unresolved, along with being credible. These are words you don't want to hear when somebody's looking at retracting your article, because, well, that's exactly what happened. The retraction itself shouldn't come as a huge surprise, and it's for a single reason. The lead researcher, along with another researcher on the team, have both been through the same song and dance before, and for pretty much exactly the same thing, although in this case the other publication was for a high temperature superconductor, this being a room temperature superconductor. So yeah. The final news item we have for you this week is all about mathematics and a sort of party trick, if you will. It's all about the Ramsey theory and finding order in disorder. The key with this is to try and find a scenario in which 3 things are explicitly related, or 3 things are going to be totally unrelated in a common network. This is normally applied to social situations, such as a party, where the people you invite will either already all be acquainted, or strangers. That is, if you pick 6 people, that 3 of them are going to know each other, or 3 of them are going to be completely unknown to each other. As far as early research goes, we've been able to establish what the 4-4 number is. That's 4 known and 4 strangers, or 4-5, that is 4 acquaintances and 5 strangers. And that number is 18 and 25 respectively. That would mean that if you want to ensure that when you invite people, you meet one of these criteria, or more accurately, you don't want to meet it, you need to find the right number at the end and invite at least one less person than that specific number. So for example, if you are looking at avoiding 4 people who know each other explicitly, or 4 complete strangers, invite fewer than 18 people. For 4 acquaintances and 5 strangers, invite fewer than 25 people. But this leads us to the 3-3 example, that is 3 acquaintances and 3 strangers. And to be clear, we're not going to try and go through the formula. It's not necessarily complicated, but it's tedious and not necessary for this video. However, you can see the expression here. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.